Hi there, thanks for joining us again here on LokadTV. In today's episode, we're going to be discussing the evolution of the user experience, and in particular how user interfaces have changed when it comes to supply chain software. Unless you're a software engineer yourself, the chances are the user interface is the only bit of the software that you actually deal with. A lot of the time, when people are asked about the future of user interfaces, they refer to films like Minority Report, where Tom Cruise can be seen gesticulating in a rather cool-looking 3D environment. However, this film was released back in 2002, and it seems we're no longer any closer to reaching that vision. So Johannes, last time I checked, Lokad is still very much a 2D environment. So when's all that going to start changing?
So yeah, let's be clear on one thing. Three-dimensional user interfaces are not coming anytime soon in Lokad and pretty much in any enterprise software environment either. And the core reason it has nothing to do with technology. It's a pure matter of human anatomy, actually. Your perceptions, the way you perceive user interfaces, it's mostly two-dimensional. Yes, you have two eyes and you can see some depth, but it's mostly a two-dimensional perception. So basically, a third dimension doesn't add much as far understanding the world goes. And then when it comes to replicate, what Tom Cruise does in Minority Report, which is standing like that for 10 minutes. I mean, just try to stand with your arms up for 10 minutes, and you will see that you're super tired. And by the way, that's why the 3D mouses, which were invented something like 40 years ago, never took off. I mean, you have to be an athlete to use that. And it's very funny because in many ways, the future of user interfaces is pretty much the opposite of what people expect. And it's a great paradox, I think, as far as software design is concerned.
Okay, so if you're going to crush my dreams on what these future user interfaces are going to look like, perhaps you could share with us your vision of what these user interfaces will actually be like in the future. Perhaps you've got an example that you could share with us here.
Yes, and the interesting thing about the future is that the future is already there. It's just not evenly distributed. So if you want to have a look at the future, you should look at your anti-spam software. The sort of software that filters all those interesting propositions coming from weird countries that you've never visited, and that offers you, selling you dreams to get rich. That's your anti-spam filter, all of that. But the interesting thing is how this piece of software does it. I mean, it does it silently, diligently, and if it's very, very good, you never even realize it there. So you see, a very, very good piece of anti-spam is the sort of things that just do it for you so that your inbox stays very clean, but you barely notice that this thing even exists. And that's, I believe, the future of most of the very capable machine learning driven software. It will be something that is ambient and nearly invisible. And it's probably the opposite of the very coolish three-dimensional user interface that you can see in Hollywood movies, but because there is nothing to see, so it's not very visual.
Well, I certainly like the sound of anti-spam. It'd definitely go a long way to reducing the amount of time that's wasted reading those really interesting business proposals from Nigerian princes and princesses pretending that you're going to get rich sometime soon. So that's definitely an interesting concept. But that's really my end user perspective. So how about companies? How can they trust this piece of software if they're never really interacting with it?
So that's an interesting dilemma. As a company, you have to pay for your employees. And so any time they spend doing something is time that you ultimately pay. So here, what do you want for your software, for the employee, for the software that your employee are using? You can look for something that is a bit Facebook-like, so it's social, it's interactive, and people enjoy it a lot, but it's also a lot of interruption. So in the end, it's very funny because if you put something that is very like a social network, people would enjoy it a lot, But it's a bit like if you were paying people to spend even more time in front of the coffee machine. It's good to have, a couple of times a day, times to relax, to re-energize, and to brainstorm with your colleagues. But if you have that all the time, how do you get the work done? So companies, they are paying their employee to actually get some real work being done. And the way I see it, paid entertainment is not going to cut it. So that's what it's the dilemma here for the company. How are they going to trust it? To trust a piece of software? Well, probably they should not trust too much a piece of software that demand constant interaction from their employees either, because it's probably the opposite of what being productive means.
Okay, so if you look at this now from a sort of supply chain perspective, a lot of these apps weren't very interesting in the first place. So when it comes to sort of demand forecasting software, what can we expect of those user interfaces for the future?
So indeed, supply chain software, especially the user interfaces associated to supply chain software can be relatively dry, let's say it. But for example, as far forecasting demand goes, you can make it, I would say, more coolish, more interactive. And actually, there is something that has been quite trendy, is to have like collaborative forecasts, where you say, oh, let's have everybody involved, where everybody can see the forecast, can interact with the forecast, potentially modify the forecast, toy with the settings, everything. And if you have hundreds of products, or worse, thousands, then just imagine how much time get lost into doing these sort of things, with all people spending their entire day looking at curves, time series that you can extend into the future, and trying to tweak them. So in the end, it's a massive productivity drag. And even if it looks cool and interactive and social, it's not going to boost the results of your company. And so that's why for any company of any scale, the end game is not collaborative forecasts. It's like end-to-end automations with zero edge cases in the forecast.
So what you're saying there is that people won't actually be included in these forecasting. Is that what you're sort of saying there?
Yes, exactly. And so you want to achieve end-to-end automation, and you want to remove all the productivity drag. So if people have to do something, it has to be something that positively contributes to the solution, not time that is consumed from one day to the next just to repeat the same thing over and over and over.
Okay, so if people aren't actually included in these forecasts, how can we actually trust the results? I mean, we're still going to need some sort of metrics in order to assess the software, and I'm assuming some sort of human's going to have to be involved checking these metrics. So how would this actually work in practice?
So it's interesting because here you have two perspectives. You have the end user perspective. It would be, in this case, we are talking of companies, so that would be the client company perspective. And we have the perspective of the software editor, or the company who actually write the code and the overall machine learning infrastructure that generate the forecast. So from the end user perspective, so the company that has a supply chain to operate, what you want to look at is outliers, aberrant behaviors, just like for your anti-spam, actually. You don't really care about the metrics of your anti-spam. I mean, you probably never compile as a user any statistics of how many emails are correctly filtered, how many emails are incorrectly filtered. You don't do that. What you do is once in a while, you check your spam folder, and you just have a cursory inspection just to look if something wrong was misclassified as spam, and this is it. So what you're looking is for an outlier, which would be either an email that is spam that lands into your inbox, nevertheless, and the other way around, an email that is clearly not spam that end up in your spam folder. That's the outlier. In demand forecasting, the outlier would be a forecast that is like excessively large or way too small. That's your outliers. That's what you want to look at. So that's your end user perspective. And you don't need to compile statistics. You just want to get rid of all the outliers, literally all of them. And then from the software company perspective, when you want to improve a forecast, you don't want to take the data set of one company at one point of time and see how you can improve one metric. No, what you want to do is you want to collect all the data sets that you have. And for example, Lokad, we help over 100 companies to optimize the supply chain. So we have well beyond 100 data sets to optimize. And you want to make sure that your forecasting engine is consistent and improve consistently over this entire mass of data set, not just one. And you don't even want the mass of data sets alone. You want to do a full back test going back in the past, 1 week in the past, 2 weeks, etc., etc., etc. So that's how you approach this game of optimizing the whole forecasting process.
Okay, so about these metrics, could we not share them with companies? Would that not help the companies gain a greater trust in the software?
It could, but the reality is, do you need the metrics for your anti-spam? The problem is that the metrics that are most relevant nowadays, they are, for example, the cross entropy that is used for deep learning. And by the way, cross entropy has been used for more than a decade now for anti-spam as well. Most of the advances in artificial intelligence have been driven by this cross entropy metric that is maybe a bit mysterious, but that is extremely powerful. So first, it's typically metrics that are very unusual, that applies to probabilistic forecasts. So and they are vastly superior to, I would say, the classic metrics such as the mean absolute error or the mean absolute percentage error, which are completely dysfunctional and still kind of the standard practice in supply chain. So you see, we have a challenge, which is first we have to communicate numbers, but that are very, very alien to most companies. The second challenge is that actually when you want to build a forecasting engine, like we did at Lokad, having metrics is like 50% of the technological effort. So those metrics, they are not like just a small add-on at the end of the work of designing a forecasting engine. The metrics comes at the very core, and they represent literally 50% of the complexity. So it means that it's not that we don't have metrics. We have literally hundreds of them. And in practice, it doesn't prove very helpful to share those walls of metrics, just because it would take literally a book to explain what all those numbers mean. And in the end, it generates even more confusion than being really helpful. So that's why we typically suggest that instead of trying to see all those metrics, trying to focus on the outliers, look at, don't try to reverse engineer the metrics in the software. It's very complicated and not necessarily very helpful. Instead, focus on the decisions that are generated as a final output of the system, and focus on the outliers, so that the decisions that are obviously wrong, and those are the ones that needs your most immediate attention, because they are the ones that are going to cost you a lot of money from a supply chain perspective.
Okay, so we keep on mentioning this word anti-spam. So if the future of software is going to be like this anti-spam, the difficulty lies in that supply chains are inherently a lot more complex than just filtering out a little bit of spam. So would this actually work in practice? Can we actually have supply chains working on full autopilot?
So yes and no. Indeed, a supply chain is a very complex system. It's a lot of humans, a lot of machines, a lot of software involved. So there is no hope that a piece of software with default settings can actually do anything. Anti-spam is working, silently, without any need to even set up your anti-spam, because all the email boxes are pretty much the same. So you can have like you can have an automated setup for the anti-spam as well. You don't need to do anything specific. But indeed, when it comes to optimize to the optimization of the supply chain of a given company, you need to understand the strategy of the company, the financial incentive, the pain points of the clients, and tons of things. And those things cannot be discovered by the software itself. I mean, maybe in a century when we have I would say, human intelligence level, artificial intelligence, something that is as smart as a very smart human, or maybe even smarter than a very smart human. Maybe this kind of software will be able to have a completely automated setup for a complex supply chain. But right now, we are still very, very far from such a situation. So that's why we have at Lokad those supply chain scientists. So and the supply chain scientists need to do this setup, and they need to be very productive at doing the setup, which is basically modeling the supply chain of a given company in a way that is very correct and very productive. And that's where the user interface challenge strikes back, because then to do that, you need to have something that is like an entire integrated development environment to do that.
Okay, so this integrated development environment, it sounds very complex, and it definitely seems to lack a lot of that glamour of the Hollywood perspective we started off discussing in today's episode. But is there anything else to do other than just let people write a bit of code here?
Yes, and indeed, it's completely non-Hollywood style. I mean, it's like writing code, indeed. But the reality is that writing code is a craft. And if you have good tools, you can do it, I would say, faster and better. In particular, correctness by design is very important in supply chain. Why? Because the whole idea of doing trial and error, it can be nice in theory, but in the real world, in the supply chain world, it's just extremely costly. You don't want to do like thousands of mistakes on purchasing just to get it right ultimately. That would cost millions of dollars of euros. So you want a programming environment that helps you to achieve this correctness by design. It's something that is extremely hard to do with a general programming language, just because there is so many programming puzzle that you can tackle that it's a nearly impossible challenge to do anything that is very profound and very efficient in the general case. Fortunately for us, and fortunately for our clients, we are not trying to solve a general programming problem. We just want to solve the problem of quantitative modeling of supply chains. And that's why we have like our own domain-specific programming language that is called Envision. And Envision is built in with tons of features that are precisely designed to offer a degree of correctness by design as you write the code. So you can have productivity with plenty of fancy features like autocomplete, but you can have also many degrees of correctness by design by what is called static code analysis. So it's an analysis that can be triggered even before you actually execute the code. Just to give you an example, that would be the way you can detect that the variable that you've introduced somewhere in your script has no impact on any decision that you take for your supply chain. What does it mean? Either it means that it's an economic factor like a stock out penalty or whatever that you forgot to plug into your recipe. So that's one situation, so that you will be reminded you forgot to plug that. Or the alternative is that it's just something that you discarded and you forgot to just remove it entirely, so it's dead code and can confuse your colleague that will take over this piece of code to optimize your supply chain later on when you're not there because you're in vacation or anything. So yes, indeed, there is probably a future for user interfaces, but the way we see it at Lokad, it's much more in this programming environment and all the smart widgets that you can have to make your supply chain scientists that are expensive and scarce more productive and efficient, as opposed to have a 3D user interface just like Tom Cruise in Minority Report, where you can slide things and draw charts visually and everything.
Great.
Absolutely.
Well, I'm afraid we're going to have to wrap things up there, but thanks for taking the time out to discuss with us about user interfaces of the future. It's definitely been an interesting conversation, and as you said, it's really interesting to compare the Hollywood vision of reality with what actually will happen in the future. So thanks very much for tuning in to today's episode. As always, we're here to help if you've got any further questions on user interfaces, and we'll be back very soon with another episode. So until then, we'll see you very soon.